Lewis dot diagrams for compounds. Lewis dot diagrams are used to show the valence electrons and the interactions of elements. All elements want to have a full outermost energy shell. All elements in the A columns, with the exception of hydrogen and helium, need 8 valence electrons to complete their outer shell. Hydrogen and helium only need 2 valence electrons in their outer shell. This is called the octet rule. In this video, we are using shoes to demonstrate how electrons pair up with each other. When you have a lone pair, you do not take it apart or mix it with other electrons. You leave them alone, the same way you wouldn't mix a pair of shoes. Single electrons must find another electron to pair up with to create a shared pair. A single shoe is an incomplete pair without its matching shoe. The same goes for electrons. A single electron is an incomplete pair without another single electron. The 2 electrons will bond to create a shared pair, just like 2 shoes put together make a pair. Let's talk about diatomic elements. There are only 7 diatomic elements: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. We will use nitrogen as an example. Diatomic molecules must always be in a compound with itself when it's alone. They can not only consist of one atom, meaning nitrogen will always be N2. To draw this, draw the Lewis dot structure for nitrogen twice. There will be a triple bond between the 2 nitrogens, meaning that there should be 6 dots in between the 2 ends. Which means there will still be one lone pair of both nitrogens. To draw this, put a lone pair on the outside of each end. Let's start with methane. Start by writing the Lewis dot diagrams for each element individually. Carbon has 4 unpaired electrons and needs 4 more single electrons to complete the octet rule. This is where the 4 hydrogens, each with 1 unpaired electron, come into place to fix the gaps, to create 4 shared pairs. Now let's move on to dicarbon dihydride, better known as ethane. Start by writing the Lewis dot diagrams for each element individually. Each carbon has 4 unpaired electrons and needs 4 more to complete the octet rule. Both of hydrogens have 1 unpaired electron. The carbon will bond with each other, creating a triple bond. This leaves 1 unpaired electron on both of the carbons, which creates an open space for hydrogen to come in and fill in the open space. Now let's move on to carbon difluoride dichloride. Start by writing the Lewis dot diagrams for each element individually. Carbon has 4 unpaired electrons. It needs 4 more to complete the octet rule. Both difluoride and dichloride only have 7 electrons, which leaves 3 lone pairs. Both need one more unpaired electron to complete the octet rule. We started with 2 fluorine. We are rearranging the electrons as needed, so that the single electrons can create a shared pair, once both of the fluorines have completed their outer shell. Carbon still has 2 unpaired electrons that need to be shared. This is where the 2 chlorines come in to complete not only their outer shells, but also carbon's outer shell. To check that all elements have completed the octet rule, draw a circle around each element and their electrons to make sure the elements all have 8 electrons. The outer elements, fluorine and chlorine, should each have 3 lone pairs and 1 shared pair, while carbon should have 4 shared pairs.